Hello. From now on until the end of semester, we'll consider the analytical separation techniques. Four chapters are devoted to analytical separations. So, in this chapter, you will learn the fundamentals of analytical separations, and then the gas chromatograph, liquid chromatograph, and electrophoresis will be treated. Okay, since four chapters are devoted to the analytical separations, so these techniques are so important. As you know, the four chapters are devoted to acid-base chemistry and also to the electrochemistry. So those three subjects, yeah, acid-base chemistry and electrochemistry and separation, techniques are essential parts of analytical uh, the chemistry. Okay, and so um, and this the separation techniques have been widely used to detect this very small amount of the analyte. Okay, and especially not only in chemistry but also in other fields like biochemistry, biology, okay, and life science. Yeah, virtually in every field, and also the pharmacology and medicine, right? And these techniques have been widely used. So I really urge you to study carefully and acquire a good knowledge of the analytical separations. Okay, let's start. Okay, as usual, um, the front page of this chapter shows some applied application of the this analytical separation, okay, which is measuring silicones leaking from breast implants. Okay, and usually silicone, the compounds are very inert. In this case, don't be confused that silicone. This is not a a solid silicone. Okay, this means a silicone compound. Okay, and the spelling is, you see, it has E, silicon, SILICONE. Yeah, but the solid silicon spelling is different. There is no E, SILICON. Okay, but the pronunciation is the same. Don't be confused. Okay, the silicones means the silicon containing compound like these ones. Okay, anyway, uh, the woman want to be implanted, breast implanted with the silicone compounds. Okay, for the beauty it's alright, yeah, perfectly okay. But the problem may be after many years. Okay, after maybe several years, maybe some of these species may leak from the implant into the blood and into the tissue, and it may affect your health. Okay, so it is important to detect, you see, these silicone compounds, if there uh, there is a leakage or not. Okay, and yeah, this one, let's see, the spectrum shows there is some leakage, definitely. Well, uh, this is actually a chromatogram, right? To detect these compounds, first of all, you have to you have to take samples of maybe from your blood or from your tissue, okay, and then you have to separate. Yeah? Otherwise, there are so many uh, the components, yeah, in your sample, so it is very difficult uh, to study. Yeah? So first step is the separation, okay, and of course the separation itself is not a simple matter. Anyway, After separation, you detect using mass spectrometry. Okay, so this spectrum was obtained by the selected ion monitoring gas chromatogram. Okay, the GC by gas chromatography, you separate. Okay, you separate the compound, and then you use the mass spectrometer as a detector. Okay, in a previous chapter, you learned how to operate. There are several ways of operating mass spectrometer. One is the selected ion monitoring. Okay, you first set the master charge at a specific value, and then you run both gas chromatograph and the mass spectrometry, and then you can detect a specific mass, okay, specific master charge the ratio. All right, and as you see, well, I think there are several this master charge of 281 was set, right? And then there is a small peak here and another peak here, and okay, and when you set the master charge at 441, you see there are maybe two peaks at the mass of 355. There is a small peak here. Okay, uh, so let's see what kind of silicon compounds are used as a breast implant. High molecular mass polymethylsiloxane. Yeah? The general formula is like this one, right? It's used as the gel in breast implants. Yeah? And but this chromatogram uh, shows the traces of siloxane 5 years after. Okay, after 5 year old breast implants were removed. Okay, and approximately 1 to 2% of silicones in breast implants are low molecular mass materials. Okay, but this is the high molecular mass material, but 1 or 2% is low molecular mass materials that can leak from intact implants and travel through the circulatory and the lymph systems to take up residence in lipid rich tissues. Okay, so these compounds, some of them leaks, and they stay in the lipid rich tissues. Okay, and so analytes were extracted with the hexane from 1 milliliter of blood plasma, to which the internal standard, this one, what was the name? Well, I don't know, was added. Okay, so this one, this pig, is used as internal standard. All right, and what are low molecular mass materials that can leak from the intact implant? This one. Okay, let me see. So I'm sorry. This one, this is the name is T3, and the molecular mass is, I think, 300. Oh, I'm sorry. Well, I don't know here. Well, why this happens here? Anyway, some of these, the compounds are detected by this selected ion monitoring gas chromatography. Okay, the point here is that the detecting a very small amount of compound. Yeah? Look at this concentration. Is ppb order, 3 ppb, 28 ppb. Okay, yeah, like that. And those low concentration can be detected by separation, and then um, uh, detecting by mass spectrometry. Okay.